So now we're going to more formally investigate zero and negative exponents and come up with rules. Here's where our rules are going to end up going in this box, but before that we're going to do some different ways of looking at these. So if I do 2 to the 5th power, that would mean 2 times itself 5 times, which is going to be 32. 2 to the 4th power, 2 times itself 4 times, which would be 16. 2 to the 3rd, 2 times 2 times 2, which is 8. 2 to the 2nd, which is 2, and 2 to the 2nd, which is 4, and 2 to the 1st, which is 2. So what I can see about my exponents is they're decreasing by 1 every time. 5, 4, 3, 2, 1, so logically my next exponent would be 0. What do you notice for your pattern here? To get from 32 to 16, 16 to 8, 8 to 4, 4 to 2, what's happening every time? If you noticed that it's always being divided by 2, which makes sense because we're multiplying by 1 less 2 each time, that would make my next answer in the row 1, because 2 divided by 2 is 1. So that's just a pattern though, that's not going to prove why this is the case, so let's do some more investigating. I know that 5 times 1 is 5, 4 times 1 is 4, b times 1 is b, anything times 1 is itself. So that would mean that if I'm going to multiply x to the 3rd by some unknown number and have it stay x to the 3rd, that missing number would have to be the number 1. But I also know that if I were to multiply x to a power, like here with x to the 3rd, by x to some other power, since I'm adding, my shortcut allows me to add my exponents. So let's say I wanted to, instead of multiplying it by 1, x to the 3rd times x to the something, knowing that because they're both x's, I'm going to add the 3 in that missing number, and I want it to stay the number 3, well then that missing number would have to be a 0, because 3 plus 0 is 0. So what that means is that if x to the 3rd times 1 is x to the 3rd, but that x to the 3rd times x to the 0 is also x to the 3rd, then these two things must be equivalent. X to the 0 power is 1. And so what that means for us is that anything to the 0 power is going to equal 1. The only exception is you can't do 0 to the 0 power. So with that in mind, try examples 1, 2, and 3. Pause the video, press play when you're ready to check your answers. Every answer is 1 because we're raising everything to the 0 power. So notice that it doesn't matter if it's a whole number, a fraction, or an integer like a negative number. Anything to the 0 power, no matter what it is always going to be 1. Now let's do a similar investigation for negative exponents. So we'll start the pattern again, we just won't start quite as high. So 2 to the 2nd is 4, 2 to the 1st is 2, 2 to the 0 we just learned is 1. So again, our exponents are decreasing by 1 each time. 2, 1, 0. So logically, our next exponent would be negative 1, followed by negative 2. Again, I can see that to get from each number, I'm dividing by 2. So if I were to divide 1 by 2, I could write that as 1/2. And then if I were to divide 1/2 by 2, I could write that as 1/4. Let's write this as a power of 2. So 1 over 2 would be the same as 1 over 2 to the 1st power. And 1 over 4 would be the same as 1 over 2 to the 2nd power, because 2 times 2 is 4. So what I can see here is that I've got a negative exponent that became positive when it ended up in the denominator. Let's look at this one more way. So I know that if I'm dividing exponents when the base is the same, I'm allowed to subtract those exponents. On the earlier investigation, that meant that since I'm dividing 2 to the 4th by 2 to the 5th, I can do 4 minus 5, which is negative 1, or I can put it in expanded form. So 4 2's on top, 5 2's on bottom, which is going to cancel out all my 2's on the top, leaving behind a 1, and then just a 2 on the bottom, which is the same as 1 over 2 to the 1st. So 2 to the negative 1 is going to be 1 over 2 to the 1st. So if I go back to the first page, what this is going to mean for my rule is that if I have a number to a negative power, it's going to become 1 over that same base, but to the positive power. So by moving the item to the denominator, the exponent becomes positive. Let's go back to our negative exponent examples. And if you're wondering, why can I not leave my answer with a negative exponent? It's because we don't know how to evaluate with a negative exponent. It's kind of like the same reason why you wouldn't leave an answer as 2/4. You would simplify it to 1/2. Negative exponents are considered to not be simplified. We also wouldn't know how many slots to draw. If you think about something as straightforward, let's say as 2 to the 5th power, That exponent of 5 is telling me to draw 5 slots with a 2 on each slot. If that exponent were suddenly negative, I can't draw negative 5 slots. So I need the exponent to be positive before I can evaluate with it. So in my first example, I noticed that my x has a negative exponent, so I'm going to move it to the denominator of my fraction and make the exponent positive. My placeholder in my numerator is going to be a 1 for now. Similar with number 2, so I'm going to bump the 4 down, and its exponent would become a positive 3. The 1 takes the place in my numerator, and then 4 to the 3rd power means to do 4 times itself 3 times. So 4 times 4 is 16, times 4 is 64. You give examples 3 through 6 a try. Pause the video, press play when you're ready to check your answers. So on example 3, my y has a negative exponent, so I'm going to bump it to the bottom, leaving behind a 1, and by bumping it down, my exponent becomes positive, 1 over y to the 4th. On example 4, the base this time is the negative 8, so that whole negative 8 has to get bumped to the bottom. Notice that it's still in parentheses, so that way the exponent is touching not just the 8, but the negative sign as well. And then that would mean to do negative 8 times itself. Negative 8 times negative 8 is positive 64 for a final answer of 1/64. On example 5, a couple ways to think about this. One is that since my 7s are dividing, I'm allowed to subtract their exponents. 3 minus 5 is negative 2. But then because 7 has a negative exponent, we're going to bring it to the denominator, and then 7 times 7 is 49. If it's easier to think about this at the start, you can look at how many 7s you have in the numerator and the denominator. I have 3 7s in my numerator and 5 in my denominator. That means I have 2 extra 7s, and those 2 extra 7s are in my denominator. So logically, it would make sense that the 7 squared would be in the bottom of the fraction. Similar on number 6, so I could, because I'm dividing, I could subtract my exponents, and 3 minus 6 is negative 3, which is going to bump down and become 1 over x to the 3rd. Or you could look at your x's at the start and realize I've got 3 x's on the top, 6 x's on the bottom. That's an extra 3 x's that are located in my denominator. Now that you've seen those, give examples 7, 8, and 9 a try. Pause the video, press play when you're ready to check your answers. So in this case, what I did was I looked at the number of variables in the numerator and the denominator, and I decided where there were more and how many more there were. So if there's 7 b's on the top and 12 b's on the bottom, that's an extra 5 b's in my denominator. An example 8, 6 r's on the top, 13 r's on the bottom is an extra 7 r's in the denominator, 1 over r to the 7th. 13 x's on the top, 16 x's on the bottom, that's an extra 3 x's in my denominator. So now let's look at what happens if the item is already in the denominator. I promise there's going to be a shorter way to do this, but for right now I'm just going to use color to help me through. So my numerator is 1 and my denominator is y to the negative 3. So what I could rewrite that is 1 divided by y to the negative 3. So I could keep going, 1 divided by, but then I know that my blue y to the negative 3 can turn into 1 over y to the 3rd. I also know that when I divide fractions, I change it to multiplication. So this could become 1 times the reciprocal, which is y to the 3rd, which is going to make my final answer y to the 3rd. Or if I just look back at the original, what I can see is that my exponent, which was negative, was in the denominator, and it ended up in my numerator. So on example 11, if I look at my fraction, I've got a base of 2 being raised to a negative exponent, and so what that's going to do is it's going to bring my base of 2 up to the top and change the exponent from negative to positive. And then 2 to the 2nd means to do 2 times 2 for a final answer of 4. So if I go back to those rules on that first page, I'm going to add one extra rule, which is going to be if I have 1 over a to the negative m, that's just going to become a to the m power. So essentially what's happening is if something has a negative exponent in it, it's going to move its place in the fraction. So if it's in the numerator, it's going to go to the denominator, and if it's in the denominator, it's going to go to the numerator. And in making this move, the exponent changes from negative to positive. So for our Shark Tank fans out there, we know that Mr. Wonderful always says, "Stop the madness, there must be a better way." One way I like to think about negative exponents is as the game Whack-A-Mole. We all know how that carnival game works. A teeny tiny mole pops his head out of the hole, and we use a little mallet to whack it. I like to think of my negative exponents as the moles that need to be whacked. So if you see a negative exponent, you're going to knock it and it's going to go down. Now what about those moles that are already down that you accidentally hit? They're going to bounce off the floor and they're going to go up. So let's look at example 12. I have 3 items on example 12. I have 4, x to the negative 2, and y to the 3rd. So I have 3 different items. I'm scanning through to see if there are any items that have negative exponents, and I see one here. So I'm going to knock the x. And what's going to happen is the x is going to go to the bottom of my fraction. So I've got my fraction bar, and now the x to the negative 2 is going to travel to the bottom, and by doing that, the negative part of the exponent is gone. Normally we leave behind a 1, but this time I already have 2 things as placeholders. I've got a 4 and a y cubed. So my final answer here would be 4y to the 3rd over x to the 2nd. The 4 and the y get to stay where they are because they don't have negative exponents. We're only hitting the x because it has a negative exponent. On example 13, I've got 4 items, 6, x to the 2nd, y to the negative 4th, and z. Which one are we going to whack? You're right, we're going to hit the y. The y is going to go down to the bottom of my fraction, and in doing that, its exponent is going to become positive 4. The remaining items are just going to stay where they are, 6x to the 2nd, z. Final answer, 6x to the 2nd, z, all over y to the 4th. Let's look at example 14. So I've got 3 items, a 5, an x to the 3rd, and a y to the negative 2. 5 and x to the 3rd don't have negative exponents, so I don't have to worry about them. But what I do need to do is I need to bump the y to the negative 2. Now it's already in the denominator, so the only place it can go is up. So it's going to join the 5 and the x to the 3rd, and it's going to become y to the 2nd. By moving it up, its exponent changes from negative to positive. I want you to pause the video and try examples 15, 16, and 17. Press play when you're ready to check your answers. So on example 15, I first noticed that I had 2 x's that were multiplying each other. Because they're multiplying, I can add their exponents, and 3 plus negative 8 is negative 5. So now both x and y have negative exponents, which means they both need to get bumped to the bottom. So that's going to become 1 over x to the 5th, y to the 5th. On example 16, my base of 12 has a negative exponent, so we're going to bump it down. That becomes 1 over 12 to the 2nd, and 12 to the 2nd means to do 12 times 12 for 1 over 144. On example 17, the first thing that I did was I got rid of parentheses by applying the negative exponent to each of the 3 and the 7. But since it's a negative exponent, I can't evaluate it yet. Remember, a positive exponent, like over here of 2, means to draw 2 slots with a 12 on each slot. That wouldn't be possible with a negative exponent. It's not possible to draw a negative number of slots. So 3 is being raised to the negative 2 power, 7 is also being raised to the negative 2 power. Because they have negative exponents, they're going to change their spot in the fraction. So 3 in the numerator is going to go to the denominator, and 7 in the denominator is going to go to the numerator. By making this swap, their exponents become positive. 7 squared, 7 times 7 is 49, and 3 squared, 3 times 3 is 9. My final answer is 49/9. So if you're in Algebra 1, you're going to continue through with these extension examples. One hint that I'm going to give you for each of these is to do RPS. Raise. So raise any items that need an exponent to that power. You're not going to evaluate, you're just going to show that you're giving them the power. Kind of like in example 17, how we showed that both the 3 and the 7 were receiving the power of negative 2. Once you raise everything to the power, then you can make any exponents that you have positive if necessary. Then you can simplify. So raise, positive, simplify. Pause the video, try examples 1 through 6, press play when you're ready to check your answers. So in example 1, the first thing I'm going to do is I'm going to raise everything inside the parentheses to the 3rd power. So 2 is receiving the power of 3, x is receiving the power of 3, and y to the negative 5 is also receiving the power of 3. Now because it's an exponent to an exponent, I get to multiply to get negative 15. The next thing I'm going to do is I'm going to make my y exponent, which is negative, positive, by bumping the y to the denominator of my fraction. The 2 to the 3rd means 2 times 2 times 2, that's 8, and x to the 3rd, those 2 items get to stay in the numerator because they already have positive exponents. On example 2, there are 3 items inside the parentheses, all of which are receiving the 3rd power. So 3 to the 3rd power, x to the negative 2 to the 3rd power, so I get to multiply their exponents to get negative 6, and y to the 2nd to the 3rd power to get y to the 6th. Of my 3 items, the one that's going to get bumped down is x, making its exponent become positive, and then 3 to the 3rd, remember, means to do 3 times itself 3 times. So 27y to the 6th over x to the 6th. On example 3, I applied the fact that these are dividing, so I get to subtract their exponents, that shortcut. -1 minus 2 is -3, which then would make me bump down my 5 to the denominator, having a positive exponent of 3, and then 5 times 5 times 5 is 125. You could also think of it as bumping this 1 5 down to join the other 2 5s that are already down there, which would get you right to this 1 over 5 to the 3rd before you simplify. On example 4, the first thing I'm going to show is that I'm raising both the 2 and the 3 to the -2 power. But again, I can't evaluate with negative exponents until I make them positive. So I'm going to swap their locations. So 2 will go to the denominator and get an exponent of +2. 3 will go to the numerator and get an exponent of +2. And then 3 squared is 9 and 2 squared is 4 for a final answer of 9/4. Example 5. So the first thing I did was raise both the items inside the parentheses, the 2 and the x, to the -2 power. Everything else I just wrote as it is. That was this, raise. Next, I focused on making my negative exponents positive. So on the top, I have a base of 2 with a negative exponent, so I bumped that to the bottom and gave it a positive exponent. X also had a negative exponent in the numerator, so I bumped that to the bottom and gave it a negative exponent. This -4 doesn't move. Its exponent is actually technically +1. Even though it's a negative number, it doesn't have a negative exponent. So the only 2 items in this problem that are moving are the 2 that's on the top with a negative exponent and the x that's on the top with a negative exponent. Everything else stayed where it was. So I've got -4 times 2 squared times x squared that got bumped down times the x squared that was already down there, and then a y to the 5th in the numerator and a y to the 2nd in the denominator. Now I can simplify. So y to the 5th divided by y to the 2nd becomes y to the 3rd, and those would be on the top because there were more y's on the top. X to the 2nd times x to the 2nd would be x to the 4th, and then 2 times 2 is 4 times -4 is -16, for a final answer of y to the 3rd over -16 x to the 4th. On example 6, I began by bumping down the x to the -2nd. There was nothing to raise because there's no parentheses that have an exponent attached to it. So I dropped down the x to the -2 and made it x squared. Everything else stayed where it was. Then I simplified each as I saw it. So 4/8 reduces to 1/2. X to the 2nd times x became x to the 3rd, and then y to the 4th over y to the 6th became y to the 2nd. And this one I kind of thought of visually as there's 4 y's on top, 6 y's on bottom. That means there's 2 extra y's that happen to be on the bottom.